So for the first keynote, the Yang will chair the first keynote. So please, I want to give my microphone to Yang.
Thank you, Anjong. So it's my great pleasure to introduce you Ralph. So Ralph Lamel will give the first keynote. You probably all know Ralph is a software engineer at Facebook since 2018. But before his new life, he was a professor in computer science at University of Koblenz-Landau in Germany. So you probably know Ralph through his work on mega models, MapReduce, or type checking. But you should be also aware that Ralph is the creator of the Summer School on Generative Transformational Techniques in Software Engineering and the International Conference on Software Language Engineering. And recently, Ralph actually published a great book on software languages, syntax, semantics, and metaprogramming. And I want to congratulate him because this book actually has been chosen as an outstanding academic title in 2019. So thank you very much, Ralph, for giving this keynote. And I will pass you the microphone now. So please, the floor is yours. Thank you.
Thank you. Okay, sound check. Everyone can hear me, so I should probably also share my screen. One sec, please. Share screen. Okay, I have it. Yeah, it seems to work, right? Okay. Yeah, I mean, thanks a lot for having me. This is like for many of us, I guess, my first virtual keynote. I really appreciate it. I'm very happy to do it. I miss you all, guys. I miss the ICPC community. Yeah, let's try to get the best out of it. Also, apologies for this weird title, Comprehension Challenges at the level of software ecosystems and global software engineering. Yeah, it has to do with the kind of scope that I want to choose for talking about program comprehension this time around. So let me provide some context here. So I'm working as a software engineer, sort of in research, in the infrastructure layer of Facebook. So infrastructure, we use this term to talk basically about all the support for the actual software engineers that develop apps and products, right? So basically infrastructure is responsible for providing all the language services, version control, continuous integration testing. And also we have more specialized areas of infrastructure that focus then on data infrastructure, or yet another one on AI infrastructure. So basically this is hundreds, if not thousands of engineers providing the support so that all these apps like WhatsApp, Facebook, Instagram, etc. can be built. Yeah, that's where I'm basically working in. And I think of Facebook as a bunch of software ecosystems, really. So the way how we do app development, we don't really simply use Android or iOS ecosystem. We have our own layer for doing app development. And also when we do backend services, we have an entire kind of ecosystem for that. And also we have hundreds, if not thousands, of internal tools. And again, for that, we also have an ecosystem. And the way how we do releases and bug tracking, etc., that's also kind of has the flavor of an ecosystem. Even when we use languages, yeah, we use languages that everyone uses, like Hack and Rust and whatever. But we always have our own layers here so that we integrate these languages better with our other systems, for example, for continuous integration or for bug tracking. And we have deep integration, deep customization in the IDE. And so this is why it feels like software ecosystems. And I guess it's also clear that a company like Facebook is, of course, about global software engineering. We have engineering offices in various time zones. We have not just since work from home time, have geographically distributed teams. I'm working for a team that's London-based, but I'm working from home now in Germany. But that team is part of a larger team that is mainly MPK-based, but also in Seattle. And my projects, they involve also various teams from various places, mostly US. We have all kinds of different employee types. And there's a lot of changes always going on about team changes and role changes. So this is really global software engineering. So I have picked 3 areas in which I want to identify some relevance of program comprehension and also point out some open problems and stimulate future work in these areas. So these are areas that I have been working in. It's about developer workflow, about ownership of software and data assets, and also about code review automation. Actually, the last one I'm just getting into, but yeah, that makes it even more exciting to talk about it. Anyways, yeah, so, and everything I'm going to say is sort of about automation, right? So how can we use sophisticated heuristics, machine learning, to help in these areas, okay? That's going to be like, and by the way, yeah, you see my cats showing up here, but this is Ada Lovelace. She's obviously trying to analyze developer workflow as we see right now. So developer workflow analysis is about analyzing the workflow of our developers. And I'm going to focus on one particular problem here, what we call work item prediction. There is a related industry track paper coming up on this. I'm not going to repeat everything we are going to say there, because that paper is a bit more on the actual system. I want to focus here on the challenges. But nevertheless, if you want to know more about the actual work on this, there is an industry track paper coming up. So what is work item prediction? It's basically about finding out what work item an engineer is working on. I mean, obviously this is a good idea, right? If you can figure out what your engineers are working on, but there's actually really good reasons to do that, right? So here's the incident response scenario. So we use an alert system at Facebook, which kind of is alerts are triggered when some sort of metric, for example, a performance metric drops below a certain threshold, or something else happens that needs attention, right? And so these alerts then need to be analyzed, right? So we have so-called on-call rotations. People are picking up the alert, they look at some dashboards, they run some database query, they do whatever it takes to understand what the alert is and how they can address it, right? Obviously, it would be very valuable if you could help these people and giving them sort of recipes as to what steps they have to follow to address the alert. Of course, you can try this with normal documentation, but you know, documentation gets outdated. Maybe it wasn't ever there for this particular alert type. So it's a nice idea to try to record the steps perhaps a more experienced engineer takes in addressing the alert. However, how do we know, you know, along the day, when exactly that engineer is responding to the alert or is doing something else, right? So this is the work item prediction challenge. How do we know whether someone is actually working on responding to that alert? And here's a completely different scenario. It's about diffs. Let's say we want to figure out how much time is spent on diffs. Diff is the Facebook term for system changes, right? So basically what's committed for review and then eventually accepted, hopefully, and then lands in production somehow as released. So this is what we call diff. And of course, we want to know how much time is spent on a diff. Maybe we want to know this at a corporate level, right? To kind of monitor whether we are getting less or more productive. We might want to monitor this at the individual, you know, product level or at some other levels for pretty much the same reasons. And so this means we should record all the activities that go into a diff, such as, you know, actually publishing a diff, reviewing the diff, landing the diff, and whatever else it takes. The challenge here, indeed, again, is how do we know exactly when someone is working on a diff? So let me illustrate this with this image here. So this is a timeline of a developer. This is all about works on different diffs. So the developer eventually publishes a diff here, another diff here, and then later on also reviews a diff. And so the problem we have here is we have coined the term dark matter for that purpose. We have activities for which we don't know exactly to what diff they are related. So for example, sometime earlier, the person might query some database. Why was the person doing this? Does this relate to this diff or that diff, or maybe neither of them? And likewise here, the developer seems to read some documentation. What is this related to, right? So this is what we call dark matter. We cannot easily count for these activities in terms of the work item prediction here. And then we also have something in between like gray matter. So if someone commits a version locally, and this has to do with how we work at Facebook, but it's not too different from elsewhere. You know, you first commit a version locally, nobody else sees it yet. It's just an intermediate state, and eventually, maybe after some splitting and folding of commits, this might be turned into an actual diff, right? So yeah, it's a gray thing because you know, we can use some clever heuristics to figure out that this commit maybe ends up in this diff rather than that other diff. So this is not dark matter, so you can do it. But some of these things are tricky. And so what we do here is we have worked on probabilistic work item prediction so that we try to figure out by means of heuristics and machine learning components how these different dark matter activities relate to the underlying work items. So for example, here with this gray component, we have indeed succeeded with a heuristic, and we have figured out, okay, this relates to this particular diff. And then with this query database kind of activity, we have figured out with a very high probability, 0.8, that this relates to this review activity. And then for this documentation activity here, we don't really know. There's different probabilities, and they don't even need to add up to 1 because maybe we are not aware of all conceivable work items, right? So yeah, there are different probabilities here how this documentation action relates to all the diffs around. So you might wonder, why do we have this dark matter? And this is really like software ecosystem, global software engineering kind of result. So the tools that we have, and we have literally thousands of tools, they don't track the work items consistently. Some of course do, others don't, right? The tools are not fully integrated. Yes, we use IDEs. Yes, we use continuous integration, tool support, etc. But many activities are outside the integrated experience. And so the logging that is used in these hundreds and thousands of tools is of course not designed with workflow analysis in mind, right? They log something, but they might not log all the right things to be sure that that we know what work item is involved. And honestly, the developer workflow, it's complicated, and by its very nature, it's somewhat unstructured. So, and add to this that developers engage in context switching, right? So they don't work from start to finish just on one thing and then we start the next thing. That's of course completely unrealistic. So there's a lot of context switching going on. And by the way, this issue here that we have dark matter that relates to a fundamental notion in process mining. So in process mining, you sometimes speak of so-called process unaware systems. These are systems that are not designed, not implemented in a way that they allow you to easily understand the workflow instances as they proceed. And it very much relates to the notion of case ID recovery, or the lack of case IDs. In process mining, we don't necessarily know at all times for each activity what a person is working on. So, and the tooling situation is really complicated in a company like Facebook. So we have tools that come and go, the functionality changes, the interface changes, like suddenly we use certain tools through the IDE rather than through the CLI, and the integration situation changes, the locking, the schema and the semantics of what is locked changes, right? The best practices change, what tool to use for what, and the use cases also change. And that makes it really a challenge to do this work item prediction, right? And so this also means, because we have so many tools, it's unrealistic to say, okay, let's just reverse engineer them, let's just re-engineer them so that they all provide perfect logging and we don't have this issue with work item prediction, right? It's just unrealistic. And here, a little bit of insight on the context switching argument. So what we see here is, again, a timeline of a developer, a few days on the x-axis. And on the y-axis, we basically see different diffs, different system changes. And so, for example, these yellow markers here, they indicate that a diff was discontinued, abandoned, or these green arrow signs here mean that the diff was actually landed. And here it was started, and these rectangular events here, this is about reviewing, and these very small dots here that you might not see, these are about new versions being pushed out, and so on and so forth. So you see there's a lot of parallel work going on for these diffs. And you see, for example, also here, apparently not much is going on here, but this is only because we don't know about all the actions, right? So obviously something has happened here, some further investigation has happened here. We just don't see it because this view only knows about the high confidence activities that definitely feed into these diffs. We don't know about these FerDB and documentation, yet other activities that they are not shown here. Okay, so what you can infer from this context switching problem is that we definitely need much more than time proximity kind of argument, right? And we also really need more than high confidence events for which we definitely know someone was working on this, right? Because if we don't do this, we can just not reconstruct when someone was working on what, right? And so just a few words on the system that we built at Facebook, a few more words about this in the industry track paper. So basically, yes, what we do is we integrate all the logs that we have, and it's very tough integration work, data cleaning, some means of abstraction over the event log. But nevertheless, there are no diff IDs or around. So, and then we kind of define time windows into this dark matter. So we basically split up the timeline by 10 minutes. And so our expectation is that for this kind of granularity of 10 minutes, we can probabilistically predict whether a certain engineer was working on a certain diff. To this end, we also have to have a notion of what we call candidate work items. These are those work items, in our case, diffs, that the person could possibly have worked on. So what we do here is we essentially travel a bit back in time and also a little bit into the future. We just look at all the diffs that show up as high confidence candidates before and after the day of prediction. And these are our candidate items, and then we just try to see whether we find any dark matter activities for them. Yes, and then we have a bunch of ML heuristic components so that we can probabilistically rank all those candidate diff items in the sense that we want. And so let me just briefly connect this to some related work just to show you that this is not a solved subject, and that historically related work, both in the process mining community, but also in the program comprehension community, has focused on slightly different problems. So this is a classic paper here where process mining was applied to an MSR context. It basically managed to sort of discover the bug life cycle, and also it was powerful enough to identify different developer roles. But the issue of case ID recovery, or diff ID recovery, or whatever you want to call it in this context, commit ID recovery, is totally non-issue there, right? It's already nicely scoped by a given bug and a given number of commits, or within a fork or whatever, even if you make it complicated. But there are no other activities involved that would even trigger the work item prediction challenge, right? Or here's something else. Yes, this one, the second one, is not limited to MSR and repository specifically. It's about the somewhat complicated IDE experience, and it tries to understand what workflows are taken in the IDE and about the frequency of certain actions. Yeah, but this is also basically scoped already by some task, right? I want to get some work done within the IDE. Different developers maybe try this out. They use different workflows, and then you get different frequencies, and you get to see different workflows, but there is no discovery of any work items, right? And prediction, though, is of course studied in this context. So the last paper here, for example, is about prediction of future developer behavior, but it's more about, you know, someone is working on a certain development task. Now, let's just predict what the engineer is doing next, the next step in the IDE. I mean, for example, whether the engineer is likely to continue debugging or rather is finished debugging and starts editing, right? Completely different prediction problem, nothing to do with work items. And some more papers here. This is a bit more from the process mining community. So for example, the first paper is one of the few papers that tries to recover case IDs in workflow, I mean, for workflow instances. And it does so essentially by also assuming that workflows are sort of executing, I mean, workflow instances are executed in parallel, very small number. And then it basically looks at the probabilistic, I mean, it tries to infer the probability of the sequences of actions from the workflow. And again, these workflows are super, super simple. I mean, remember, we're talking about massive parallelism in our workflows, and we talk about hundreds of thousands of tools. Yeah, so an idea that pops up a lot and is very useful is event abstraction. We have done event abstraction a little bit in our work. We haven't used machine learning for this. We have done this sort of a little bit manual, but it's still a very good idea. And then two more applications of machine learning in process mining context, one related to concept drift and the other one representation learning. But that's also very cool work, but again, it doesn't address the work item prediction challenge. I mean, the case ID recovery challenge, if you like. So let me get to the second topic. But I mean, the conclusion here is, you know, at the scale of something like Facebook, there's both open problems from a process mining perspective and also from a developer workflow analysis perspective. Okay, the second topic I want to get into is about ownership management. And yes, so now you see both of our cats. This is Ada Lovelace, and the other one on the left is Kathleen Booth. Yeah, so there's also related industry track paper on this. So, and that paper, especially also the presentation, focuses a little bit more on the system behind this work. I will not focus that much on the system. I will just try to present more the challenges in this area. Okay. So what is ownership management? This is basically the simple way of understanding ownership management. Each software and data asset at Facebook or similar companies has the most accountable owner at all times, right? And by software and data asset, I mean things like database tables, Hive tables in particular, pipelines for in a warehouse, ML models, and of course also source code files in a repository, configurations. We have a few hundred asset types at Facebook. And what does it mean to be an accountable owner? It means that you are a reliable and accountable, a knowledgeable point of contact for all means regarding, you know, whatever needs attention, right? Reliability, security, privacy. And this is basically ownership management, to make sure that everything has the most accountable owner at all times. Okay, and that clearly also benefits from automation, and it's essentially also a program comprehension problem, because, you know, we need to understand the actual assets. We need to understand how people work with these assets and more. So just to give you an idea how the system behind ownership management works. So there's this, we have built a system called Honesty at Facebook, and it basically works like this. We start from all the logs that basically tell us who has interacted with what asset at what point in what way, right? Of course, we have the actual assets. From those, we also extract all kinds of features, right? All kind of knowledge. In some cases, actually, the assets themselves also record ownership information. Like we might have annotations that tell us, okay, this file, this configuration is owned by that person or by that team. At least at some point in time it was. And so we also have meta stores around, especially in the data infrastructure context. These meta stores also keep track of ownership signal. Right, and so we extract features from all these things. We compose feature vectors, and we also use certain what we call labeling events to understand when ownership has changed, right? And from this, we get labeled data, I mean, ground truths. And so we can build an interpretable model that basically delivers us ownership recommendations or ownership predictions, which we then sugarcoat so that it become explainable, I mean, digestible by users. So we can feed them into tooling or in project management and tasks. And so eventually people can accept them, reject them, or escalate them or whatever. So this is the kind of systems we build for ownership management using machine learning and heuristics. And this is quite challenging, as you can imagine. Because again, we talk about hundreds of different types of asset classes. We talk in some cases about many millions, if not more, individual instances. Yeah, we talk about teams that change all the time. We have complex relationships, like some assets have more structure, they break down into parts, right? And obviously these whole part relationships should also be somehow be obeyed by ownership recommendation. We have ownership decay, right? So just because someone put a certain team into some file, claiming that this team owns this file, doesn't mean that this team is going to own it forever, right? So we need to watch out for that. And so there's many more problems. There's also problems at the machine learning level. For example, we tend to use what's called monotonic features, which essentially means in our context, the greater the value of the feature, the more likely we have ownership, right? And so we have to be careful that our ML system obeys these rules. And in the end, it's very important that we provide explainable recommendations. So for example, just, some deep learning approach in itself without anything else wouldn't work, because these recommendations need to be explainable. Actually, preferable, the models ought to be interpretable, because we need to convince people to actually accept ownership, or we need to sufficiently inform them so that they can reject ownership, right? So a bunch of challenges, and the paper goes a bit more into them, and especially also lists some related work. Situation is really very involved. Like here, for example, I'm just pointing out to the issue of team level ownership, right? So think about a problem. So as far as the features are concerned, we are mostly relying on individual interactions of, actual engineers with actual assets. So this is the signal that we are getting at the lowest tier. And we have to translate this typically into team level ownership, because, obviously teams, for example, on-call rotations should act on any incidents in privacy or security, and reliability. So this translation process from individual signal to teams is quite tricky. Teams are changing all the time. They are split, they're merged, teams are terminated, and individuals also move around, right? So I might become program manager tomorrow. So all the signal that I provided is no longer relevant because I'm no longer engineer. I'm exaggerating a little bit. But yeah, or we have like what's called hackathons. Someone is in one team, but is already considering starting maybe in another team. So it's already working informally for another team. So how do I now count this expertise and the ownership signal towards what team? So it's really tricky. So this is another way to summarize the challenges in this area, right? So the challenges have to do with the fact really that we have a heterogeneity of the owned assets. You might compare this to the well-established area of reviewer recommendation that we all know, the program comprehension, MSR, etc. communities, right? Compared to reviewer recommendation, where you might take into account the actual change and maybe the bug or whatever, we have hundreds of different assets, so we need to deal with quite different features here, but this also needs to scale, right? We can't afford to do a new system for each new asset class, so there needs to be also some generosity, so that makes it tricky. We really need to be dependency aware, right? It doesn't make sense I mean, we need to take into account that we understand that someone is depending on something, so that maybe if there's no other owner, for example, really available, then, you know, if you depend on it, you own it, right? That sort of stuff. And obviously the dependencies are quite involved in systems at Facebook. So we need to take into account not just call graph information, we also need to take into account variability and package level. And when it comes to tracking down how, for example, privacy relates to products, we might also need to deal with traceability. And then when it goes into the data warehouse, we need to use lineage and provenance information. And that's also basically a consequence of the heterogeneity situation that we have, right? Okay, and then there are also workflow and organizational aspects we need to take into account. We need to understand project management history. And what I was talking in the previous part, also we need to do some sort of process mining to understand who was interacting with what asset for what reason. Does this interaction imply ownership signal, and how to rank them? Okay, and then again, in an ML context, we need to really be careful about trying interpretable models as much as possible, still also making the recommendations, the individual ones, explainable, and also supporting counterfactuals, because yeah, you might want to understand what would need to change so that I would not be the owner, that maybe that other team would be rather the owner, or you know, why am I not suggested as an owner? That would be done with counterfactuals. And also just a few papers here on that subject, just to show you that this is not a solved problem, right? So here we have sort of a state-of-the-art paper on reviewer recommendations, and that one tries to kind of score these different approaches and tries to figure out the best approaches. But in all this work on reviewer recommendation, of course, you don't really deal with the heterogeneity of the asset classes that we have to deal with. And then there's the neighboring field of code authorship attribution. It actually is not that relevant, right? As you probably know, that field is about is more related to plagiarism and malware detection. So it's more like watermark based. So we also consider such tricks, but we use typically other signals, not watermark, to find ownership signal. All right, and then like the last paper, this is also really well-known paper that surveys all kind of code-based change impact analysis techniques. In a way, it really is providing state-of-the-art, well, there's now newer stuff, but back then, on dependencies. But, you know, obviously, again, it's just code-based, right? So we have a much more complicated situation. We have services, you know, back end, front end, we have web entrance points, we have the whole complicated situation in the data warehouse, another complicated situation with the machine learned workflows, right? So that also needs to be generalized. Okay, and then the last part I want to talk about is about code review automation. That's actually an area I'm just entering. But I mean, it has been a concern in the larger team that I'm a member of. So I'm working in what's called a probability team. And some of you might know the big code efforts in that larger team that I also now aim to support. And so this is about code review automation then. And so just a quick look. I mean, here's a cool paper from Sainer last year, which tries to figure out, you know, if you like, the state of affair for code review. So you might say, okay, this code reviews, this is a solved problem, right? Is it all great? No, and I mean, this paper really nicely figures out a bunch of remaining problems, and some of them are also relevant in the context of Facebook, as far as I can tell. So the point they make here is there's a lot of confusion regarding the actual rationale of the system change, right? The non-functional requirements are not clear. And it's also difficult to complete the code review because you're maybe not so familiar with existing code, right? So I have this, right? I mean, if I go on vacation for like 2 weeks, then when I come back, suddenly I don't recognize the project, right? So, I mean, of course, I can always start and go through all kinds of diffs and do all kind of code search, but it's really difficult to complete this work on code review, right? And on top of this, there's also, of course, tool integration issues and communication issues that people just misunderstand each other. I mean, that's just that this paper just providing good takeoff for motivating that indeed work on code review is still very important. So I'm providing some more context here. I'm just picking out some papers on code review or code review automation to kind of sketch a little bit the state of the art in this field. And towards the end of this, I will then come up with some sort of compressed proposal where I think challenges are really waiting for. So the first paper here, not very new one, but still quite important to kind of get this point that we are really doing two things with code reviews, right? It's about functionality defects versus evolvability, or other people say maintainability defects. And it turns out that it somehow happens that more time seems to go into the evolvability defects. And maybe this is good. Maybe we should use static analysis to find all the functionality defects. And indeed, this other tension between, you know, code review and static analysis has also been looked into a lot, right? So the second paper here, for example, shows that if you go for state-of-the-art static analysis configuration, then you can already capture, what was it, something like 16% of those things that otherwise pop up in code review. And if you even customize static analysis to those projects and try to capture a bit more through static analysis tools, then you can get rid of another 16 or 17% of what would otherwise be addressed by code review. So yeah, so we need to figure out the right balance between looking for functionality effects, and we need to figure out how much time we want to put into evolvability effects, because there's also the issue with, is it now really an evolvability defect, or is it just a style issue? Is it really important? Is it, you know, or is it maybe just subjective? Are people just distracting themselves with, you know, focusing on small evolvability effects, I mean, style? And so these are sort of open questions, right? Here, the third paper by folks at Microsoft. So they also kind of figured out pretty much like missing documentation or hard to find documentation as a problem, and also understanding how it all fits together, how basically this change is integrated into the bigger system, right? And which then also means, how do I test it as a reviewer? How do I, you know, how do I see that it's working, right? So that's also, and then by the way, the last paper is also by the Microsoft folks, very, very related, but they point out a different challenge. They point out the challenge that, of course, we are advised generally to always have relatively small diffs that focus on one issue. We still don't have an automated way of, splitting up commits so that they definitely separate the different concerns, right? Few more papers here. First one is on test-driven code review. So this is the paradigm where reviewers are advised to focus on the tests as they were added or changed, rather than focus on the changed functionality first, right? So, and this is a very interesting kind of general question, because you might say, maybe I can reduce reviewing time by just having more solid testing approach, right? But what they find, for example, is that yes, if you use test-driven code review, you find pretty much the same functionality defects, but you might actually miss evolvability effects quite a bit in the actual code rather than in the test code. And well, that's sort of problematic, right? And then the second paper, it uses a survey to figure out basically how different kinds of audiences deal with different kinds of coding styles. And I would like to summarize their findings in a very brutal manner by saying they basically find that good style is often or sometimes subjective, and sometimes you might even say arbitrary. So this is really worrisome, right? Because if you have all Facebook engineers focusing maybe too much on style issues, this adds up to a big amount of money, right? So obviously there is some interest here in addressing that sort of problem, making sure that code reviewers are both fast, so they don't lack the understanding, the documentation that they need, and they also don't waste their time on irrelevant stuff, maybe, right? So this is why we discuss this. And the last paper, essentially, it's about code smells, and it tries to figure out what is the state of the art, and this ICPC last year, what is the state of the art of ML approaches for code smell detection. And I would like to summarize it, because it's just one line, by saying by the way, it's still difficult to use ML. It's expensive, and it's still difficult to use ML for smell detection. Which means, we are not yet at the point that we just have the magic ML system that learns all the smells, all the linting rules and everything, and it will just basically eliminate most of the work of our code reviewers. There's all kinds of products out there. We essentially use some version of Fabricator, right? Facebook, highly customized. I mean, this is no longer this Fabricator. And there's other products, JetBrains, Amazon, and Codacy. I mean, all these products increasingly also try to incorporate some ML, and certainly try to improve code automation. So I see basically these themes here when it comes to automation of code review. And I will again associate a few more papers with these themes, not too many, but yeah, just to provide some structure on how we might want to further improve code review, right? So there's the issue of signal selection, right? If I want to make sure someone is paying attention to all the signal coming from, let's say, static analysis or elsewhere, I have to select it in a clever way so that I don't overwhelm the person and that it arrives in time, right? Code fixes, yes, we want to suggest code fixes so that reviewers don't have to come up with these code fixes or these things go completely unnoticed. We might even want to suggest comments where they are missing. We might want to summarize commits in a way so that people better understand what's going on. At Facebook specifically, we also have this separate notion of test plan. This is, if you like, a section of the summary that helps you understanding how you would need to walk through the change and see that it really works, right? It sort of complements testing. And then review decisions, we might want to automatically reject commits, right? And we might also want to partially automate what comments are provided as part of reviewing. So this is a paper by my colleagues at Probability here, predictive test selection, right? They focused on trying to select the tests so that they can quickly run the most important tests, and in this case, not just be quicker for the code reviewer, but also save infrastructural costs, right? Just one example. Or here's some related work on code fixes. First papers also by folks in the probability team. I mean, I have no credit to take here, any of those. So basically it uses some sort of tree differencing and anti-unification to kind of learn common fixes, right? Or the second paper is that a little bit more sophisticated, uses a neural network for learning code fixes. And the third paper is maybe a little bit out of line, but just to point out that there is neighboring areas that might end up in this ballpark. So this is essentially about API migration, right? Which doesn't necessarily need to happen before or during code review, but probably not. But it's a very similar idea, right? So basically try to learn, in this case, the method mapping. And in this case, they just use relatively simple IR methods. Oh, yeah, also an ICPC paper last year. Yeah, you can think of this as a code fix learning approach, right? And here are some papers on comment automation, comment generation, right? So, for example, the first paper, ICPC two years ago, it essentially turns the ask into a sequence and then uses neural machine translation idea to actually turn it into a natural language, which then can be used as a comment, right? And the second paper, just this year, pretty cool. They go farther than that. They also incorporate program analysis in different ways into this comment generation context. So yeah, so they are careful about kind of the semantics of the program in how they possibly generate the comment, and also they optionally interpret the comment as sort of an assertion and then are able to connect it to the area of static analysis, right? Also really cool. And there is very little work I'm aware of that would really qualify as a comment summary. Well, there is this work here on how to explain a patch. So how do we adequately summarize commits, right? I think this is largely still an open problem. I mean, there is related ideas, for example, when it comes to forks, right? This is the second theme here on the slide, but it's a slightly different problem, right? When I want to summarize forks, it's maybe more about understanding, are there maybe related forks, and should I favor this or that fork that are very similar? It's a different problem, right? So the first one here on the slide is maybe closer to that. It tries to understand what is a good patch explanation, right? But ultimately, we really want to support really good, commit summaries. So another area here, making review decisions automatically, right? There is, for example, this sort of work also uses deep learning, where it basically tries to predict whether the review is accepted or rejected. I don't see much that this is immediately useful in how things work at Facebook. I mean, maybe a refinement thereof, right? So it could maybe say, okay, you really need to revise this diff because of some fundamental problem. I mean, so it's not so much about rejecting and accepting right away the diff. I mean, like the way we work at Facebook is that we always do some, non-trivial code review. So there's always some discussion between the author and the reviewers. I mean, except for the most trivial diffs, of course. And here we have work that is trying to generate review comments. So they are both similar insofar that they use deep learning again and embeddings, embeddings at the level of the code and also the comments to suggest comments that the reviewer could, want to also give, right? And yeah, this is very cool work, and I think I want to spend some of my time in that sort of direction. And I also realized it almost feels like automatic linting, right? I mean, in a way, it feels like we are able to learn linting rules where we then provide an actionable or focused comment to the author so that they know how to improve the code, right? But it's different, right? So, I mean, if you think of automatic linting rules, they better be almost 100% reliable, right? There should be no noise because it's very painful if I have to make shut up a linting rule, right? So for this stuff to be useful, it doesn't need to be 100% perfect, right? So I can always, as a reviewer, I can always kind of quickly glance at it and maybe accept it. Or also as an author, I can possibly easily dismiss some of these things, right? So this is also very cool stuff. So here's my summary of the challenges in code review automation. I think I leaked them already pretty much all. So how to make nitpicking obsolete, right? I mean, how to avoid that people waste their brain cycles on finding trivial, perhaps even irrelevant issues. Also interesting, right? How to know that this is a good code review. Because this is also quite important, right? If sometimes people are not sure, should I wait for another code review, right? And so if we had a better way of assessing the confidence, the reliability of a review, this would also make us go faster, right? And then I really think, and I was clear about this, I really think we need better ways of providing commit summaries, right? And especially in the case of Facebook, this would also extend, I will say a few things about this, to test plan. And really the question is, like, as part of the commit summary or otherwise, what sort of additional information should we provide? I mean, quite often all the information is there, right? I mean, we have already, like, we have code indexing around, but what information to include and how to render it and how to prioritize it so that it helps code reviewers, right? And also related to the kind of evolvability and possibly functionality effects discussion. What is anomalous code, right? It's only starting that researchers look into this. And just to connect these challenges with the situation of Facebook, and again, I think it's very similar, other companies like Google and Microsoft, etc. So when you look at the code review process at Facebook, it involves quite a number of entities. I have just listed the most obvious ones here. So you have the diff summary, commit summary, diff summary. You have the test plan, which says, what should you look out for? How do you see that things work? You have the actual commit, I mean, at the level of code, right? You have continuous integration signal through which you get some static analysis that you might not necessarily have had locally in your development environment. And then there might be a task or several tasks, as we call it, and this is our project management notion, linked to the diff. This task might be about a bug or about a feature. There might be also an alert. I was mentioning alerts earlier on, the reason for this diff change. And actually we also have the notion of, well, we don't internally call it incident, but let's say incident. I mean, some more severe problem that really needs to be fixed. And there might be also connections between different diffs, right? So we might say, okay, this diff is a mitigation for that diff, which is the root cause for this incident or this alert. And so these are just the most obvious things that are on the table here. And my hypothesis is that in order to improve code review automation, we need a combination of, more ideas from the areas of knowledge graphs, right? We need to stop just, messing around with links and clicks. We need to have a more ontological view on this, a knowledge graph supported view on this, which we then can also appropriately surface as summaries. And we need to have a notion of change impact analysis that scales up to the level of the systems, like those. And again, this change impact needs to be actionable, understandable for the code reviewer. And we also need traceability recovery. For example, it's not acceptable that I need to look around and look into the task and another div and that summary just to understand how it all fits together. We need to apply traceability recovery to connect those different aspects, often also involving natural language. Yeah, so this is my message from regarding code review automation, and I'm coming to the end of this presentation. So you might say, are these all the areas where I see comprehension challenges? Well, I mean, I'm obviously limited by what I have seen in Facebook, what I'm working on, but I have seen other areas where comprehension challenges also very relevant, right? I've been involved in work on privacy in some sense, and like there you really need a very powerful notion of provenance or lineage, and that really requires, problem comprehension work. And in a way, also when it comes to reliability, obviously the systems at Facebook are so complex, any sort of reliability incidents response, you better have some tribal knowledge or some way of using tools, etc., to recover all the dependencies so that you can address the problem. So these are just two more, and that's it. That's the end of my talk. I think I finished a little bit early, but that was always the intention. So, so I'm happy to take some questions. So I think I will stop sharing screen, or should I continue sharing screen?
Up to you. Maybe keep your screen shared in case questions happen on some slides. So first, thank you very much. I think we should all clap virtually or loudly. So you can also use, everyone can also use their reaction button on Zoom. So thank you very much, Ralph. It was great, great talk, amazing work, impressive work. So because it's virtual, I think we will try first to take questions from participants who can unmute themselves. So maybe if someone has a question, they can raise their hand, and I will try to see on the list of participants if anyone has a question. Oops. Yeah, it's hard to see in Zoom. So maybe if anyone has a question, maybe they can unmute themselves, right? And ask the question. Anyone?
Vadim.
Okay,
Yes.
simple question, right? So thank you, very, very insightful. And I was wondering, what are your thoughts on the links of this to company guidelines and company coding standards and so forth, right? Because obviously, developer workflow is defined to some extent to what they want to use, but to some extent to what they are forced to use by the company, right? So in some companies, code review, for instance, is not a thing. So it is still done, but it's not being done in a structured, documented way, and therefore all code review is dark matter, right? So what do you think?
I mean, I'm obviously biased towards the level of automation and the ambitions regarding automation at a company like Facebook. So I cannot easily give advice or have an opinion on this broadly. I can only say that we try to use linting super aggressively, right? So we try to always improve our linters, and this only gets us that far, right? So we notice that when we use machine learning based systems, we can always, more automatically do new things. And I think it's very interesting whether ultimately we are able to understand you know, the scope of these rules, because I mean, obviously, if I subscribe to a certain Python linter, then it's going to be for everyone in the company, everyone who's writing Python, right? So, but different teams have different preferences, you know, and they want to follow maybe different styles. And so a machine learning based approach is possibly more clever here than rather asking people to configure like crazy for each you know, author review relationship, or for each team what sort of rules should be obeyed, right? So that's my only answer I have on this one.
Thank you. Thank you very much. Any other question?
Yes. Here, Alexandre Bergel speaking. Yes. No, thank you very much, Ralph, for your brilliant talk. Really, thanks. Can you jump on slides 23? You know, maybe. So, I mean, you mentioned that the open problems is the code graph. Can you tell us a bit more about that? So I haven't checked the industry paper that you mentioned here, but maybe can you give us a glimpse of what is really the problem with the code graph? So there are many tools around to actually extract code graph. Not many are good actually to do something useful with those code graph, you know, like I mean about in terms of visualization, but so can you tell us a bit more about that?
I mean, I'm not saying that we don't understand how to do call graphs and even at scale. I think in this particular instance, I'm more hinting at the fact that ownership would need to obey these kind of dependencies, right? So, I mean, I was giving a very simple example. Suppose you are the only person calling into this library, right? I mean, that's the most trivial example, right? Then, and let's say this library needs an accountable owner because it seems like the current owner is not perfectly accountable, right? Then what you would do is you would use the call graph and other kind of dependencies to possibly gravitate towards the caller, right? That's what I was saying. I was more saying that we need to integrate all these dependency types of dependencies to come to a reasonable form of ownership recommendation. I think that's what I should have said at least.
Yeah, thank you.
Thank you. Any other questions? Slack, there was many interesting discussion and interaction going on. I won't go through every question because there are too many, and I don't want to, you know, spend the day here. I think maybe Ralph, you can join us later on the Slack and maybe interact with the participants during the break or later today. One question, I will just pick a question coming. So a question by Marat Akin, who asks, could developers' workflow analysis be used to predict a developer, who a developer is, and if there may be some merit in giving him or helping hand? So I think the question is really about, can you also help developers by behavior, like things like when they are stuck, or maybe when they are lost in the code, or maybe when they are not using the right framework or the right tool. Can you do that too?
I mean, the incident response scenario that I was talking about is in a way an instance of such a support. So the idea is, let's say I'm new on this on-call team. I'm in the position to respond to all kinds of alerts, the types I'm not aware of. I have no idea what to do. So I'm getting this automatic documentation that tells me what should I do, what dashboard should I go to, what sort of database query should I run, what documentation have other responders looked into around the time of solving this problem. So yeah, so we have more scenarios like this, and we generally also have looked into other prediction problems based on workflow analysis. I mean, Yeah, but there like that would be another discussion, you know, other prediction problem. But even this work item prediction problem does already aim at also potentially helping engineers.
Thank you. Are there any other live questions? So please feel free to unmute yourself and ask a question. In the meantime, another question from Dario Dinucci on your slide 20. Page 20.
20? Like this?
And the question is, what do you mean with explainable recommendation? Could you provide an example?
Yeah, I don't have a slide ready for this, but I will just say it very slowly. Essentially, the key component of the recommendation is who should own what, right? I mean, Ralph should own this database. And then part of the explanation or other ingredients, it's the confidence at which the system suggests it. First ingredient. Next ingredient is what is the rank of this recommendation on the global list of all recommendation, which is sort of related to the confidence, but it's still different. And then also what is the per asset rank? Like how many other owner candidates might get this asset recommended? Where am I in the list? Am I maybe the confidence is relatively low overall, but maybe I'm still the best owner candidate. And then we have additional aspects. We have the feature importance of the ML system, right? So what is the importance of the feature, of all the features involved? And what are the feature values? What is the distribution of the feature values? And remember, we use monotonic features. So by looking at the feature values and the importance of the feature values from an ML perspective, the user might be able to understand that, you know, they are really the one, right? So, and that's pretty much it. And this, of course, can be turned into a textual, into a structured and textual format where all these ingredients are lined up and can be enriched with some charts so that it's digestible. Thank you.
Thank you very much. Thank you again, Ralph. I think we will stop now for the questions because we will take a short break before the award ceremony. So first, I want to thank you again, and maybe we can all clap, either virtually or through the reaction button on your Zoom. So thank you, Ralph, for your great talk and answering the question. Ralph, if you could, maybe in the Slack, and we will now take a short break for 10 minutes, and we will come back at 2:30. I hope you can hear me. 2:30 for the award ceremony.
Thanks for having me. It was really a pleasure. Thank you very much.